Hey, welcome back, everyone. Today, because I am busy in a meeting, we're going to have to do this as a little bit of a math on demand. So, I just want to go through the basics of the concepts we're doing. The last time we were together, we kind of introduced the idea of sets. Now we're going to deal with how we can represent them visually through some number lines, how we can talk about them. So, um, what we're going to start is we're going to start with interval notation, which I think I would prefer that we don't call it interval notation. Instead, I would like to call it something a little bit different. I want this to be set builder notation. Okay, so set builder notation is how we define sets of numbers. It's really important in later algebra when we talk about um, like the domain and range of a function. The domain is the x values that a function could take on. The range is the y values. So looking at this number line that have drawn here, you can see I have 4 points written on that. Those 4 points are integers or whole numbers. Um, it's 4, 5, 6, 7, right? So the way that we would draw this set in terms of set builder notation is we are going to write this as open brace, and then this is the x-axis, so I'm going to start with x such that, so it's an X, then that large vertical line, such that, and then what are the values that we have? Well, the smallest value we have is 4, so X is greater than or equal to 4, but less than or equal to 7, and X is an element. I'm going to call it the integers, we could call it the natural numbers, both would be correct. And then I brace like that. One more time, what this is showing by saying this, what this verbalizes into is x, and then this is such that, and then this whole thing is x is between 4 and 7, inclusive. When we say inclusive, that means that it includes both 4 and 7. If it was exclusive, then it would be not greater than or equal to, it would just be greater than. And then the last bit of this, like the little bit of a dismount we have here, let's try this brown color and see what happens. The last bit of this is, and x is an integer. Now, in order for set builder to be correct, you need to have all 4 of these parts. You start with whatever variable you're defining. You then have that such that symbol, and then you're going to have the interval on which we're talking about. And last but not least, we have to define what values of x could possibly be. So x as an integer would look something like that. Okay? So just defining it, that's where we're at. Now, that's if we have dots. If it's dots, like we have here, what will always happen? Dots tell us this is either integers or natural numbers. Those are our 2 options. You see the dots, it's an integer, it's a natural number. If we see lines, which is what's probably, I'm not going to say it's most often, but in general, when we see lines, what we are talking about, this means that it can take any value in there. Well, the numbers that exist in this case between 3 and 8, well, that's all of the real numbers. So this is going to be, we're going to be restricted to the real numbers because it could be pi. it could be, I don't know, the square root of 17, which would fit somewhere in there. So we need to make sure that we're including all of the values that are there. So if I was going to define this in set builder notation, I would define this one as open brace x such that, well, the smallest number I see is 3, and you can see that little notation on there. It says that an open circle means that it's not included. So 3 isn't included, which means that it's going to be just the strictly greater than symbol. And similarly, it's got to be less than 8. And then here comes our thing. Because it's the line, x is an element of the reals. So what that means is x can be any value between 3 and 8 excluded, and it has to be a real number. So if we want to break that down again, that's x such that x is between 3 and 8 exclusive. And then getting back to that ugly brown color, x is a real number. Okay, so we have to be able to break those apart and be able to see what is there. I think that makes a little bit of sense. I think that that's pretty manageable. From this, let's look at another example. Okay, this is the exact same numbers, but this is a slightly different set. Because those dots are there and they're filled in, we would have x is between 3 and 8 included, and x is an element of the real numbers. Boom. I think that that's doable enough. Okay. So let's see what we can do with this. We have A, which is a set of values. That set of values, we're told, is A is x such that x is between 0 and 7, and x is an element of the integers. Okay? So if I want to write down the meaning of that, I would write down that x is an integer between 0 and 7. 0 is included. So 0 is excluded, sorry. So maybe there's a better way of writing that. Sorry. Between 0 excluded and, wow, and 7 included. All right. So we've got all of the things there. It's an integer. Check. It's because it's strictly greater than, so it's excluded, and less than or equal to, there we go. If we want to list the elements of this, so the elements of A would be, well, that'd be 1, 2, 3, 4, 5, 6, and 7. We don't include 0 because it says it's strictly greater than, and we're only including the integers, so the whole numbers in between 1 and 7, including 1. Okay, and the number would be 1, 2, 3, 4, 5, 6, That's 7. And the last step here is we got to illustrate it on the number line. These are integers, so it's dots. So it's 1, 2, 3, 4, 5, 6, and 7. That's our illustration. Again, I hope that's manageable. I think that's doable. Now, from this, we need to kind of move on just a little bit and deal with some other concepts. But I think I'm going to do that on the next video. So I'm going to pause it here, and then we will reconvene and get ourselves through these other ones. See you in a bit.